Thank you. Good turnout. I'm not expecting, wasn't expecting a lot of people actually. I've never presented on a screen this size. Very exciting for me. And it looks great, you know, no clipping even. So really, I originally titled my talk like this a while ago because I had to submit this a while ago. But I've been hearing that word leveraging so many times that it's sort of, I don't feel like using it anymore. So it's a horrible word. I'm not going to leverage anything during this presentation, and I hope we don't have to hear it again. So I'm Arnon Shimoni. You pronounced it correctly, which is respect. I'm a solution architect at Scream. I'm in my 4th year at the company. I like hardware parallel stuff. I've been doing all that kind of stuff from my university days. I don't look it, I'm 30, okay? I've been helping the company realize the product that we have with our customers. I started doing development work, I worked on the core of the product, and now I'm helping implement it. You can send GIFs to my Twitter. It's mostly about animal GIFs, not a lot of GPU stuff. You know, if you're into that, I'm into that, send it over. You can send me an email. It's easy. I got in rather early in the company, so I have my name, and I don't have to fight anyone. So I'm going to be short, but in case you do want to leave before I'm done, GPUs are really good number crunchers. Everyone knows that. You know, in ScreamDB with the GPU is fast. And I'll tell you what ScreamDB is in just a second. But what I'm saying is we sort of have to rethink the problem. It's not just about shoveling hardware and shoveling money at solutions anymore. You have that legacy databases, and they just shovel these incredible amounts of hardware, very expensive hardware, at problems. And that worked until a certain point. And like you saw in today's keynote, CPUs would get faster and faster, and that was OK. But we've sort of reached the end of that. And that's what we're seeing, and we have been seeing that for the length of the company's history. And the company has been around since 2010. And I'll show you why why we have to rethink what we're doing. So ScreamDB, for those of you who don't know, for those of you who do know, you'll have to suffer through this again. It's a GPU-powered database. You might have seen some others around here. We're not in memory. We don't rely on RAM for what we do. We have a lot of architecture going on behind the scenes. Most of what we do is software. We're 100% a software company. The interesting things about Scream is the software, not the hardware, not the GPU, not the RAM. We're focused mostly on that. And it's an SQL database. Anyone here know SQL? Yeah, OK. Everyone can use it. It's very, very easy to use. I came from MySQL before I came to Scream. And starting to use Scream is just, OK, substring is renamed substr. It's that kind of changes, right? And it's extremely scalable, and I'll show you what I mean in just a minute. My story begins at Mobile World Congress last year. You can see my ear. I'm going to use the laser. You can see my ear right over there behind our CEO. We were filmed for TV. You can see my ear again. We were showcasing our database in that conference. And we were doing that because we have a lot of installations with telcos. And we found ourselves to be really good with telcos. And we know them. We know what they're doing. We understand their business. And they've been really good to us. And we've done analysis of network events. And we've done CDR mediation and CDR roll-up and all that kind of call data records, for those of you who don't know. It's every phone call you make has a bunch of CDRs. It's not just one. Before it goes through mediation, it's a bunch of records. We've done self-optimizing networks, and we've done security, cybersecurity with telecom providers, not the companies themselves, but like the service providers to these companies. And now I'm going to show you customer behavior. So at the event, we realized that there was a lot of information with these telcos, right? They collect a whole bunch of data about you. They know where you wake up. They know where you spend most of your day. They know where you Instagram. They know how you experience the network. If it's slow, they know how many disconnects you have. I mean, they can know. They don't necessarily know because they don't invest any resources into that. Telcos are making less and less money, and when they make less money because the plans are cheaper and we demand that, they have less money to spend on infrastructure. So they know what modes of transport you use. They can tell if you're riding a bus or a train or riding a bike, and they know how close you are to your competitors. If you're walking by a competitor's store, they can know that. But the issue is, are they actually using this data? They can, but are they? And are they looking at the whole customer base? Are they segmenting it by customer type? The answer is not necessarily, because you might have heard in some other talks, we're looking to pull out the information about one customer out of billions of records. That's interesting, that's great. That's not what we do. We're looking at everything. So we said to them, there's this company called Telefonica in Spain. I'm sure most of you know them. They do this solution. It's based off Hadoop, I think Impala, and it costs a whole bunch of money. Would you be interested in doing that at your company? Are you doing it, or would you be interested in doing it? And I don't understand. It's an Asian company. Some of you might know the language. I don't speak that language. I don't know what they were saying, but I could sense they were very excited but very apprehensive because they didn't want to add another database to the mix. So we said, you know what? We'll do it for you in a single machine, though. You don't have to add hundreds of Impala nodes or expand your Exadata, which is really already expensive. And that's when we had them hooked. You could sense, like I said, I don't speak their language, but you could sense that worked for them. So their current setup wasn't really designed to do what we wanted to do. You need data scientists, and data scientists like to query things. And when you want to query things, you need access to the database. But they have more and more customers. And as you add more customers, the amount of CDRs grow. And as CDRs grow, loading time grows. And loading times growing means there are less windows to do the actual analytics. They don't have time to run the queries. And it's gotten really painful. And it's gotten to the point where they're taking breaks. And what happens is the long queries cause coffee breaks, and coffee breaks cause bathroom breaks. And bathroom breaks cause your manager to come at the exact moment you're out and say, this guy's not working. And you have an unhappy manager, and unhappy manager leads to unhappy employees. And this guy, I would call an unhappy manager. So databases that displease data scientists are all over. You have all types of databases. You have the legacy databases, which you have to do a lot of manual tuning and indexing before you access the data. You have the newer databases, things like Vertica. That still has this thing like projections. You have to create projections ahead of time. You have to know what you're going to query before you query it in order to prepare the system. You have the distributed databases. And when you start copying data from one database to another, from one computer to another, you're paying that penalty. Data has to start flowing, and it's really expensive time-wise. It's not expensive computationally, time-wise. And you have the in-memory databases, which I'm sorry, it's right after an in-memory database in here, but they're painful on your wallet. If you're doing more than a few hundreds of gigabytes, it's going to be expensive on your wallet. And you're going to run out of memory. And you're going to need to expand that database, and you're going to have to cluster it. And then we go back to distributed databases, which don't perform well with joins. So, like I said, picking the wrong database will cause you pain. These are some of the databases that this customer already had. So this is why they were apprehensive. They didn't want to add more. And these databases just add up and up and up, and you have to scale them out, and you're adding more nodes and more nodes. And I visited their data center, and it's big and noisy. I had to take my shoes off, which was very unhelpful. And there are so many different types of databases there. And Chanel recently came out with a new fashion line, and they think server farms are sexy. Our customers don't really agree. They don't think server farms are sexy. And you can see by the people they send to their server farms, they don't think they're sexy. So what we did, we came in, and I said, we'll do it in one box, and we did it in one box. We repurposed one of their old boxes. They had an HP DL380 Generation 9 lying around. We said, you know what, stick a K80 in that. They paid $4,000 for the GPU, single K80. That was the size of the investment on this project. They paid $4,000 for a GPU. And this machine, on our end, is designed to handle about 40 terabytes of data, compressed. We compress everything. So that's the size of the investment. And what we did is we gave them, we were there for like 5 days initially, and we started giving them dashboards. And this is a Tableau dashboard. It's running in live mode. It's connected directly to Scream through an ODBC connector, which comes with a product. And the fact that they could query things and see things that they couldn't see before because their system was already completely bogged down. They didn't have the time frames, the time to do what they wanted. They didn't have the resources. And when they saw us doing this on the single server, which they thought was not capable of this, you could see their eyes open, and they were asking, you know what, change this parameter. Show me 12 hours, show me 3 days, show me 5 days, show me 2 weeks worth of data, show me high value customers, show me tourists. They wanted everything. We could see the excitement in their eyes. We could see so many things that we can do with this. We can sell it to this ad provider. We can start tracking where they go, what they do. We can argue if that's a good thing or not, right? I'm not justifying what they do. I'm a sell customer as well. But they found a way to make money with this. It's not about saving money anymore. It's about making money. They had a new revenue stream that they could use. And who doesn't want to go up to their manager and say, I found a new revenue stream. I found more ways to make us money. That's a much easier sell than, I'll save you $20 a month on this and that AWS service or whatever, which is nice. It's important, but this is nicer. And like I said, I don't speak their language. You can't mistake the faces, the eyes widening and that sort of look. And this is a bunch of tables being joined, so it's not a single table. We didn't aggregate anything. We just dumped the data in, and we were ready to go. And let me show you how that solution looked. So this is what they had before. They had all their data sources pumped in through an ETL process, of course, everyone does that, to an aggregation step. And they would create aggregates based on what they wanted to query. And they knew what they wanted to query ahead of time, obviously, so they had no problem creating these aggregations. And then that would go into 80 nodes of Greenplum. And I'll show you what 80 nodes of Greenplum looks like in a second. But that took them about 5 hours. 5 hours from the point where they started to ingest to the point where the data was ready to start creating reports. Reports took another hour, so it's a 6-hour end-to-end process. With Scream, we took out most of that. With a single GPU in the machine, with a single K80, we were able to do 2 terabytes per hour ingest of the same data, right? We did not change the data. We had the same data coming out of the ETL process, going directly into Scream, no pre-aggregation, and the data was ready to be queried the second it finished loading. We compress everything. That's how we're able to get to 2 terabytes per hour per GPU. We compress quite aggressively on the GPU. The GPU is really, really good for that. It's basically free. It's a free operation as far as we're concerned. And that's 20 minutes. So once again, they were like, no, you have to show us the data. We don't believe you that this went in. They verified everything we did, which was very painful for me and one of my colleagues who we were there on the ground with our laptops. We were showing them how this works, and they're creeping over our shoulders, show me, show me, show me. That's one of the things you have to experience. 80 nodes of Greenplum, that's 960 CPUs. That's 5 full racks. It had 5 terabytes of RAM. That's a lot of money. I recently bought 16 gigabytes of RAM for my own PC. It's a lot of money, okay? And this is server quality stuff, not what I bought. So ETL time, we brought down 15 times the loading time. Querying time was also faster. It's not as important in this case because their querying time was, it's 2 hours, right? They had a bunch of reports, so 2 hours for all the reports because they had to be timed. 10 minutes in ScreamDB. And TCO, we're talking about everything, including power, including HVAC, including the amount of work that we had to do to get this running, which was half an hour of installation, but sending people over to that country were expensive. This is overall TCO for a year, $200,000 compared to $10 million with Greenplum. So I said we're creating new revenue streams. We're also saving a lot of money while we're doing that. And that wasn't a fluke, right? You can say, okay, you found one specific use case. But we've done this before. We've done it with Netezza. We've done it with Teradata. We've done it with Oracle. We've done it with Microsoft SQL Server. We've done it with Hadoop. We've done it with HBase. We've actually done it with Exasol as well, which is an in-memory database. And that was a really tough battle, but we got that as well. So this is a specific use case against Netezza, where we were doing 25 terabytes of analytics, 8 tables being joined together, it was a very complicated query. And we had not a single K80, we had 4 K80s in this instance on a Dell C4130, which is a really great device, by the way, if anyone's in the market. But just imagine, you saw Volta today. We're running this on 5-year-old cards, the Tesla K series. Imagine what Volta and what Pascal can do. We've not gotten our hands on P100s yet, but we're expecting that to be a lot more interesting. So that's all I have, really. Don't forget to rate, because otherwise they won't invite me over again. So you have the app, just click that. It takes like half a minute. And you can talk to me afterwards if that's OK. Questions? Yeah?
Yeah, we're open for questions.
Having suffered through a lot of Exadata stuff.
Oh, price-wise mostly, I assume.
No. Days of work and loading cubes and so forth. But we always run into the problem with the ETL step, and you kind of showed that you don't have an ETL step now.
No, we do have an
running
ETL
this,
step.
and that's why are you running the same ETL system they had for that phone company, or did you have some other special ETL tools?
No, we were running the same type of ETL. All we really had, so Scream is naturally an SQL database. All you have to do in order to query the database is just run, to load data, you just run copy table from path. There are some options you can set, delimiters, whatever, and it works. It just goes like that. That's all we had to do. We already had the data in flat file format, because Greenplum also accepted flat file format. That's what they had. We took out the aggregation step. So that was exactly. We prevented the loading of the creation of cubes, all the views, whatever they had before. It's just raw data coming into the system and being queried. Greenplum or Scream? No, Scream is 100% SQL based. It's relational. Actually, the internals of Scream is relational algebra. So we take the SQL, we translate that to relational algebra. We do a whole bunch of optimizations. Most of them are GPU, designed for GPU. So that's where all the really clever stuff in Scream is. It's the optimizations. I have an architecture slide, by the way. I have that as backup. It's just an SQL database with a GPU attached. But having said that, we've written all the database ourselves, from the storage layer through the parser and compiler. Everything is in-house, because we realized early on that you can't take an existing database, like take Postgres, make it GPU aware, and have that work fast. So everything is designed really to stream to the GPU and utilize the parallelism of that.
Why do you focus on the telco sector and not, let's say, retail, which is also very data rich?
Just repeat the question.
We don't focus on, I'm sorry, I'll repeat. Why do we focus on telcos and not retail? That was just an easy start. We are in retail. The Netezza thing I showed was retail. She was asking about whether 80% of commerce data actually comes from SAP. I don't know if Oracle will agree with that. It might be true. I don't know. I I have no idea.
But you're as confused as me.
I'm sure Oracle will have something to say about that. That's my point. There was a question in the back. Yeah.
Thank you. Can you go into your reports a little bit more? Is it a report server? Are they just, what kind of reports are there?
So Scream is just the database, right? We don't do our own reporting. We don't have our own visualizer. That's where we sort of differ from the other database vendors that you see at this show specifically. We connect through JDBC and ODBC. We have a .NET, Python, all those connectors. So any tool that you already have will connect to Scream. And that's what happened in the case of that telco that I was talking about. They had Tableau licenses, they have Spotfire licenses, and they're using those to connect to Scream. The reports that we ran were, some of them were Tableau reports. They also did some actual querying through just standard SQL Workbench, the open source SQL querying tool. It was one of the biggest things they tried to run was a 10-step report where they were creating all sorts of dimensions to get an understanding of where people spend their days, where they spend their mornings, nights, evenings, splitting that up into buckets. I have a single part of that query. That's one of the stages of the query. It says prod use temp 06. This is stage number 6 of that query. It's SQL. Once you really understand, it's a database. All databases sort of look the same on the interface side. You issue a query, you get a result. And the customers don't have to know what type of database it is, right? The people using Scream just know that it's a database. They don't have to be aware that it's GPU-based, that there's CUDA underneath, that the drives are connected this or that way. It's just a database. That's what we see as the most valuable, just having something that works, something that's easy to use. That's why we chose SQL and not some sort of API that might have been easier to use. We don't expose the weirdness of the GPU. We sort of hide that under the familiar SQL.
So you had that number 2 terabytes per second, and then you mentioned per hour. Sorry.
Per hour, yeah.
So what's driving that data ingest? Is it going to be the GPU memory bandwidth? And have you examined different scaling with different GPU generations, or what have you seen?
So the 2 terabyte per hour figure comes from either a K40 or a K80 card, which we're sometimes only using half of. We might split it. One half will be used for ingest, one side will be used for querying. We add more GPUs in a machine as we need to add more capabilities. We have seen that, for instance, on the GTX 1080, which is Pascal based, it actually works 15% faster than Kepler, just as a side note. The 2 terabytes per hour really comes from our ability to read fast and compress fast. So this is the GPU doing the work. And ScreamDB will use whatever the machine has to offer. It will use all the RAM it can muster up, without causing out-of-memory killer on Linux or whatever. It will use whatever it can find on the machine to get the most out of it. There might be I/O bottlenecks in specific machines. For instance, if you're using spinning disks, you might hit an I/O bottleneck. But if you're using a flash array, that sort of goes away. It will go faster. Last week I showed, I was demoing ScreamDB to a customer, and we reached 2.5 terabytes on a K40 again, but with faster storage. So as these things, as things speed up, ScreamDB will speed up as well. Does that answer your question?
Yes, definitely.
Oh, excellent.
If we don't have any more questions, we'll thank the speaker one more time. Thank you.
Thank you very much.